Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 1 paper from November 2023. This paper is worth 120 marks in total, and this is the 6th video of 6. It will focus on questions 27 to 32, which account for 18 of these marks. Eduqas Component 1 papers are non-calculator papers, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 27. Simplify 7 root 2 multiplied by 3. So when we're simplifying surds, when we're multiplying surds, we're going to do our coefficients, our integer numbers multiplied by each other. So 7 times 3 is 21. And then that root 2 is still there, guys. So the answer is 21 root 2. Question 28. Factorise 3xy squared adds 6x squared y. So when we're factorising, we're aiming to pull out the highest common factor and have the remainder in a bracket. This one is just going to be one bracket. We might have squareds in there, but we need squared terms and coefficient number term, so a constant number term on its own, guys. We don't have that, so we're going to have one bracket, but we need to find the highest common factor. So what I'm going to do is I'm going to split these numbers up. So this could be written as 3 times x times y, and then 6x squared y could be written as 2 times 3, because that's my 6, times x times y. So x times x is my x squared, y is my y. So now we're going to identify what they have in common, okay? So they have 3 in common, x in common, and then a y in common. So 3xy is our highest common factor, so we're going to pull that on the outside of the brackets. And then anything that's left with both numbers is what goes on the inside of the brackets. So for 3xy squared, we simply have y left. So we're going to put y in the bracket, plus, and then for 6x squared, we have 2 and x. So we have 2x left, so we're going to put 2x and close the bracket. Question 29. Hans thinks of a number. When his number is multiplied by 2.4 times 10 to the power of 5, the answer is 9.6 times 10 to the power of 8. What number did Hans think of? Write your answer in standard form. So what we've done is we had a number, we multiplied it by 2.4 times 10 to the power of 5, and that gave us 9.6 times 10 to the power of 8 as an answer. We need to find that missing answer, so we're going to do the inverse. Instead of multiplying, we're going to divide. So we're going to do 9.6 times 10 to the power 8 divided, I'm going to write it as a fraction and you'll see why shortly, divided by 2.4 times 10 to the power of 5. So we're reversing it to find that missing number. Now the reason why I've written it as a fraction is to make our life a little bit easier. So we're going to do 9.6 divided by 2.4. Okay, and then we're going to do 10 to the power of 8 divided by 10 to the power of 5, and we're going to use our laws of indices, our division rule. So let's start with 9.6 divided by 2.4. However you want to do this. I think I'm just going to count up in 2.4s, guys, to be honest. So 2.4 plus 2.4, so that's 4.8, plus 2.4, so that's 2, 7.2, plus 2.4, so that's 9.6. Okay, so we have got 1, 2, 3, 4 of them. So 9.6 divided by 2.4 is 4. Now we've got 10 to the power of 8 divided by 10 to the power of 5. The law of division for indices tells us if we have the same base and we're dividing, we can subtract the powers. So that's going to be times 10 to the power of 8 subtract 5, which is 3. Wants our answer in standard form, so we need to check. For an answer to be in standard form, this first number here needs to be between 1 and 10 and then multiplied by 10 to a power. 4 is between 1 and 10, so we can leave that as our final answer. Question 30. Kate is visiting London. The probability that she will go on a train is 0.4. The probability of Kate going to the theatre is independent of her going on a train. So whether she goes to the theatre or not is not impacted by whether or not she takes a train, okay? The probability that she goes on a train and goes to the theatre is 0.28. Complete the following tree diagram in part A. Okay, so let's start with this first branch. So whether or not Kate goes on a train. So remember, probabilities sum to 1, and this set of branches has to sum to 1. So 1 subtract 0.4 is 0.6. So there's a 0.6 probability that Kate does not go on the train. Okay. The probability that she goes on the train and goes to the theatre is 0.28. So 0.4 times by something would give us 0.28 as a probability. So we need to reverse that. So we're going to do 0.28 divided by 0.4. The inverse of multiplying is to divide. Now, I'm going to make my life a little bit easier. So I'm going to times this by 100 to make 28. And because I'm dividing, I've got to times this by 100 too, which makes 40. Okay, I can work with that. 28 divided by 40. If I write that as a fraction, so that's 14 over 20. I want it as a decimal, so I want it to be out of 100 so that I can easily convert it to a decimal. So I would multiply by 5. There are 5 20s in 100. So 14 times 5. 10 times 5 is 50. 4 times 5 is 20. So that's 70. So this is 0.7. Okay. So the probability that Kate goes to the theatre is 0.7. Now, these probabilities are independent of each other. So it would be 0.7 down here as well. Okay. Probability that she does not go to the theatre, well, probabilities sum to 1. So 1 subtract 0.7 is 0.3. So the probability of not going is 0.3. And we've completed our tree diagram. Part B. Calculate the probability that Kate does not go on a train and does not go to the theatre. So does not go on a train and does not go to the theatre. So we're going to do 0.6 and 0.3. We're following this branch. And when we're moving along branches on a tree diagram, we multiply. So 0.6 multiplied by 0.3. So what we're going to do here is make life a little bit easier. I'm going to multiply by 10 to make that 6. Multiply by 10 to make that 3. 6 times 3 is 18, but I've got to reverse those multiplied by 10s. So I need to divide by 10, which is 1.8, but then I've got to divide by that 10 as well, which is 0.18. So 0.18 is the probability that Kate does not go on a train and does not go to the theatre. Question 31. Show that the lines 3y subtract 12x equals 9 and 2y equals 8x subtract 13 are parallel to each other. So for lines to be parallel to each other, they have to have the same gradient. So I'm going to rearrange both of these things to be in the form y equals mx plus c, because then I can compare the m's, because that's the gradient and I want those to be the same. Okay, I want them to be the same so that I can show that they're parallel. So let's start with this one. So we have 3y minus 12x equals 9. So I'm going to add 12x because what I want to do is I want to get the y on the left hand side, everything else on the right hand side. So I'm going to add 12x. That gives me 3y equals 12x plus 9. But I need it to be y equals, so I need to isolate the y. At the moment it's 3 times y. So I'm going to divide by 3. So that would be y equals, and when I divide by 3, 12x divided by 3 is 4x, 9 divided by 3 is 3. So the gradient here for this one is 4. I'm going to do the same with this equation. So we have 2y equals 8x subtract 13. I've already isolated the term with y in, but I want it to be y equals. So the inverse of multiplying by 2 is to divide by 2. So when I divide by 2 on the right hand side, 8x divided by 2 is 4x, 13 divided by 2, I'm going to write as minus 13 over 2 because that's not what I'm interested in. I'm interested in comparing the coefficient of the x because that's the gradient. So we've got to show that they are parallel to each other. So I'm going to write same gradient, so parallel. Question 32. It takes 2 hours to empty 8 identical tanks of water using 9 identical pumps. How long would it take to empty 2 of these tanks using 3 of these pumps? So I'm going to organise my information into a table. We know that I like tables. I like to work with these just because I can get really messy. You'll have seen watching my videos that I can get messy. So let's have the number of pumps, the number of tanks, and then the time it takes in hours. Okay, so 2 hours, 8 tanks, 9 pumps. We want to know how long it's going to take to empty 2 tanks with 3 of these pumps. So we're aiming for this time here. Okay. Now, what's happening here is the number of pumps is decreasing, but the time is going to increase because if there's less pumps emptying those tanks, it's going to take longer. So we're dealing with inverse proportion here. Okay, so what I'm going to do first off is I'm going to find out how long it would take 3 pumps to do those 8 tanks. So I've got a comparison, guys. Okay, so to get from 9 pumps to 3, I'm dividing by 3, but the time's going to take longer. So the pumps have decreased, but the time is going to increase. So I'm multiplying by 3. So it would take those 3 pumps 6 hours to fill those 8 tanks. But I'm interested in how long it takes those 3 pumps to fill 2 tanks. Okay. So to go from 8 to 2, I would divide by 4. So I need to divide the time by 4. So this was an inverse proportion relationship, but this is a direct proportion relationship. If I'm filling 8 tanks for 6 hours, filling 2 tanks is going to take these 3 people less time, isn't it? So we're going to divide by 4. So we're going to do 6 divided by 4. Well, 6 divided by 4, I can simplify that as 3 over 2, which I know is 1.5. So it's going to take 1.5 hours for 3 pumps to empty 2 tanks.